Hi guys, so welcome back to my channel of Aisha's Academy, and today we're learning about circle theorems. So let's go. So circle theorems are basically just a bunch of rules that help us to work out angles when it comes to questions involving circles. So I'm going to go through all of them. So the first one is that the angle in a semicircle is 90 degrees. So I'm going to show you that example. So here's our circle, and in that half of the circle the angle is 90 degrees. The second rule I want to tell you about is opposite angles in a cyclic quadrilateral add up to 180 degrees. So again, we've got another circle and we've got our quadrilateral. Now I want you to notice that with this rule, all points of the quadrilateral need to touch the circle. So for instance, if one end is 70, the other end is 110 degrees. And for example, if one end is 80, the opposite angle would be 100 degrees. So the third rule is that the angle at the circumference is half the angle at the center. So here's our circle. So learning at school, you might be familiar with the first one that I'm drawing that matches this rule. So you tend to see it with this kind of arrow shape. And so the angle at the circumference, for instance, if we were to call that angle x, the angle at the center would be known as 2x, showing that it's 2 times the angle at the center. Or to be familiar with it, as some people may go wrong, it can also look like this. So for instance here, the point now that I've drawn at the circumference, that angle is also half the angle at the center. So be familiar with it drawn like this as well, as it can throw people off sometimes. Then the next rule I want to look at is that the angles in the same segment from the same chord are equal. So for instance, this purple line is our chord, and so the angle at the top there is literally going to be the same as the angle that I'm drawing there, which is going to be the same as the angle that I'm drawing here. And I've basically put them as the color red to represent that they're all the same angle because they're in the same segment, sharing the same chord. Another rule I want you guys to remember is that the angle between a radius and a tangent is 90 degrees. So again, here's our circle, here's our tangent. So the angle they share is 90 degrees, and that is another rule. And another one I want you to remember is that the tangent to a circle from the same point will be equal length. So here's this rule drawn as well. And the last one I want us to go through for today, or second to last one, is that the angles between the chord and the tangent is equal to the opposite angle inside the triangle. So for instance here is our tangent, and here is our chord. So notice that that red angle there and the brown one, so the red angle there is the same as the other red one, and the brown one is the same as the other brown one. And the last one is that the radius through the midpoint of a chord will bisect the chord at 90 degrees. So again, here's our circle, here's our chord, here's the line up. And notice how that midpoint is going directly in the middle of the chord, and so it's going to form a 90-degree angle. So we're going to apply these rules to some questions. So the first question, example, is here. So we need to work out what angle x is. So the first thing that I can spot looking at this is the first rule of that tangent meeting the circle, so it's forming that 90 degrees angle. Sorry, tangent meeting the radius. Then the next thing I can notice is that we've got a right angle triangle. Remember, all angles in a triangle add up to 180 degrees. And so to work out what that angle is that I've circled, we would do 180 minus 90 minus 32 degrees. And that would leave us with an answer of 58 degrees. So now therefore I know that that angle up there is at 58 degrees. As you can see, there's a straight line formed there. So we know angles of a straight line also add up to 180 degrees. So to work out the other angle there, we'll do 180 minus 58, and that will leave us with an answer of 122 degrees. And lastly, isosceles triangles have two angles that are the exact same. So again, because it's still a type of triangle, we're going to do 180 minus 122 degrees, which gives us an answer of 58. So we're going to do 58 divided by 2 to work out what x is, and that is 29 degrees. So example 2, here is our question. So the first thing that I can notice in this question is that we have to do with the angle rules, which watch my video, which I'm going to add to the top to help you with that. But the first thing I can notice is that there's an alternate angle, so the z angles, so that's why that's 58. Then also, when a radius meets a tangent, the angle is 90 degrees, so up there is 90. Then again, because I can see a right angle triangle is formed, angles up in a triangle add up to 180 degrees. So to work out what x is, I'm going to do 180 minus 90 minus 58, which leaves me an answer of 42 degrees. And then last example I'm going to show you is this question. So we have to work out what angle ABC is. Now, this one I purposely brought up because a lot of people would use the cyclic quadrilateral with the other kind of quadrilateral form. But remember, all the points have to be touching for that rule to apply. So that means that angle B is opposite angle D, and therefore we're going to do 180 minus 68 giving 112 degrees. And it's literally because the opposite angles in the cyclic quadrilateral add up to 180. So thank you for watching my video, guys. I hope that helped with circle theorem questions. Remember, with these types of questions, always write down the explanation. And for more content, please like, comment and subscribe to my channel. Thanks for watching.